Hey guys, Mr. Backerberg here. In this video we're going to look at complex conjugates and division. So remember, a complex number in standard form looks like a plus bi. If that's the case, then the complex conjugate of this is a minus bi. So for example, if we had the complex number 2 plus 3i, then its conjugate would be 2 minus 3i. And conjugates have a nice property when we multiply them together. So let's look at this example here where we've got 2 plus 3i and 2 minus 3i. I want to multiply those together. So if we take 2 times 2, we'd get 4. If we take 2 times the minus 3i, we'd get minus 6i. In the middle, 3i times 2 is plus 6i. And 3i times negative 3i is negative 9i squared. But remember that I squared is the same as negative 1. So taking negative 9 times this negative 1 in here really turns into a positive 9. We've got that 4 out in front. Here in the middle with the negative 6i and the positive 6i, those are going to cancel each other out. So then we just have to take the 4 plus the 9, and we end up getting 13 as our answer. So anytime you multiply a complex number by its conjugate, you're always going to get a positive real number as your answer. Now, one shortcut we can use if we're looking at complex conjugates a plus bi and a minus bi, multiplying them together will always yield the result a squared plus b squared. So if we use that real quick with our example down here, our a value was 2, so we can square that, and our b value is 3, so we can square that. Once we square those numbers, 2 squared is 4, 3 squared is 9, so we do in fact get 13 as that answer. So if you do have to take a complex number and multiply it by its conjugate, you can use this a squared plus b squared shortcut. Conjugates come in handy when we've got fractions that involve imaginary numbers. A lot like radicals, we don't like to leave imaginary numbers on the bottom of a fraction, so we are going to take this 2 over 3 plus I fraction, and we're going to rewrite it in standard form by using a conjugate. So as we look at the denominator, we've got 3 plus I. So we want to find the conjugate of the denominator. So the conjugate is going to be 3 minus I. So we're going to multiply by that 3 minus I on bottom and on the top of the fraction. Now on bottom, because we're multiplying these conjugates together, we can use our a squared plus b squared shortcut. The a value is 3, so we're going to square that, plus the b value, the number in front of the I, is a 1, so we're going to go 1 squared. So 3 squared is 9. 1 squared is 1. If we add those together, we get 10. So the bottom of this fraction is going to be 10. On top, I'm going to distribute the 2. So 2 times 3 is 6, and 2 times negative I is negative 2i. Now what we can do with this is actually split up this fraction a little bit. Because we have 2 pieces in the numerator and only 1 piece in the denominator, we can use a process called unadding the fractions. So what we're going to do is separate the numerator into 2 separate fractions, and each fraction is going to get the 10 denominator on the bottom. And then we're just going to look at reducing down each fraction. So 6/10 reduces down to 3/5. Then we've got minus here, 2/10 reduces down to 1/5, but we have the I attached to that. So we've taken this fraction where we had the I on the bottom of the fraction, and we've rewritten it in standard form, where we've got the real number piece first and the imaginary piece second. In this example, we've got the fraction 5 plus I over 2 minus 3i. So we're going to look at the denominator again and figure out its conjugate. So we've got 2 minus 3i, so the conjugate is the opposite of that, so 2 plus 3i, and we need to multiply by that on top and bottom of the fraction. Now again, I'm going to use my a squared plus b squared shortcut on the bottom, so my a value is 2, and my b value is 3. We need to square each one of those. 2 squared is 4, 3 squared is 9, so that denominator is going to be 13. Now on top, we've got a couple of binomials, so we're going to have to FOIL this out. So we're going to take 5 times 2 and get 10. Then we'll take 5 times the 3i and get plus 15i. Then I times 2 in the middle is 2i. And then I times 3i is plus 3i squared. Remember that I squared is negative 1. So having this I squared in here times the 3 is really like having negative 3. So if we take that negative 3 and combine it with the 10 that's out in front, that'll be 7. We can take the 15i plus the 2i to get 17i, and the denominator is still 13. Then I'm going to split up my fractions again. So I'm going to take the 7 over 13 plus we've got the 17 over 13 with the I attached to it. So we've now taken this fraction and written it in standard form, a plus bi. So we've got 7 over 13 plus 17 over 13i. That's going to be it for this video. Thanks for watching.